We keep looking at sequence and series in big questions, so let's have a look at this part of the question. In the second model, the web is made in laps. The diagram on the right shows the first lap of the web. So we can see that. We can see that it is starting and it is growing, isn't it? It's getting bigger, and that's first lap. So that lap 1, the first lap. The line segment O1, O2, and O3 in the diagram are the first 3 orbitals of the web. So what they mean is this part. That's O1, that's O2, that's O3. Okay. The length of the orbitals, so that's kind of give us the clearance that that's what it is, of the web form geometric sequence. Okay. The length of O1 is 0.5 and the length of O2 is 0.53. Straight away, what can I find from here? I can find, well, what is the value of R? Because I take term 2, 0.53, and divide by term 1, 0.5, and I find out that the value of R is 1.06. Okay, find the length of O3. So I know how do we create the sequence. We take the previous term, O53, so that will be O3 equal, multiply by our R value, 1.06. And we put that in the calculator and we find is 0.5618. Okay, so pretty straightforward. Let's have a look at next part. Write an expression in N for the total length. So again, that word total means what? All the lengths added. And when they are added, we are talking about Sn of the first N orbitals of the web. So we go to our table and we copy the formula for the sum in geometric sequence. And now we fill in our values. So the first value is what? 0.5. 1 minus R, we know 1.06, and that is taken to the power of N, divided 1 minus 1.06. So what can we do here? Well, there is few ways we can go on about calculating. So yeah, you can multiply the bracket by 0.5. You can deal with this number, but I as well want to show you something. Remember that I can write that in a different way. So what I have here is the multiplication. So all of that is multiplied by this. So when I have something on top of the fraction, what I can do, I can bring that beside the fraction. I'm not changing the value of the fraction because if I do the multiplication, I'm still going to arrive here. So that I can put in my calculator, press equal and get a value. And my value here is going to be minus 25/3. Multiply 1 minus 1.06 to the power of N. And again, we can do the multiplication here or we can leave it because there is not, they haven't given us a very specific condition. We can write that just on one fraction line if we want. That is fully acceptable answer here. Okay, let's have a look at next part. Okay, there are exactly 18 orbitals in each lap of the web. Write an expression in K for the total length of the first K laps where K belong to N. So the difficulty here is to understand what actually are they saying. Let's take our, where is our drawing? And is one thing just for me to tell you how to solve that. But if you're in the exam, you need to figure it out. And that's the difficult part. So when you are in the exam, and like, let's say you are coming to this part and you are saying like, what are they saying? Okay, first of all, you have to think, what have you done so far? So far, there is a reason why here they are asking you to create a formula. So that formula, DSN formula, what is this formula about? This is a total length. So that is total length of the first n orbitals. Okay, so that's the total length of the first n orbitals. Now we know here we are told the new information that we are told that there is exactly 18 of them in each lap. And each lap means that's a lap. Because after that, we get that if we were to draw that, we're going to go, isn't it? Something like that. Okay, so we get that. So if I was to say, well, how much of them are in first lap? In first lap, I'm going to have 18 here, isn't it? Because there is 18 orbitals. I'm going to have 18 here, therefore. Okay, what about if I had 2 laps? Well, that means I will multiply that 18 by 2, isn't it? Because I'm going to have 2. What about if I had 3 of them? Then I'm going to multiply that 18 by 3 and solve it. So following that logic, how many laps I have? K. Well, that means that that 18 will be multiplied by K. So the solution here is and that's really it. That's all what it is. But that's what I'm saying. It was difficult to kind of see, but you have to look at it in the context of the question. You have to look at it in words. What have you just calculated? That's what you calculated. The total, because you are looking at what they are telling you. What are you? Total length of the first n orbitals. So that's what it is. Total length of the first 6 orbitals, of the first 7 orbitals, of the first 18 orbitals. Yeah? Replace that letters with numbers, with a specific numbers, and then you get the idea. And then we are going to this part when the key is that we are now going into lap, and each lap is 18 of them. And that's what I've told you. If you think about 1 lap, that will be on 18. If you think about 2, that will be multiplied by 2. If you and that's how you get that is 18 multiplied by k. But in fairness, it wasn't easy to see. So as you can see, the problem with sequence and series question in your exam is not the difficulty of calculation. None of the calculation we've done here are particularly difficult. It's about understanding what you are reading and how to apply knowledge.